Assalamu alaikum, dear students. How are you? Hope you would be fine. Um, During the lectures, we basically missed some recordings of the lesson. So I tried my best to record some video lessons with you for you people. I hope that they will help you out a lot. So our first topic, what we have discussed till now, that is from unit number 1 of your book, which I'm going to show you right over here. Okay, I'm Ayaz Ahmed Qureshi, teaching you physics, and then the book you are going to follow is that is Cambridge IGCSE Physics Book 4th edition. So I hope that this book will be very helpful for you. Then its first topic, what we are going to discuss is physical quantities and measurements, right? So when we talk about physical quantities and measurements, actually that is a topic which deals with what did we do, what did we measure in our daily life. So understanding the difference in this topic, actually what we are going to do to understand the difference between scalars, vectors, and with examples, and then calculate and determine the graphical and resultant methods of two vectors which are which have mutually perpendicular components. And then we will talk about some physical quantities over here. Let's say physical quantities, they can be addressed as scalars and vectors, or they can be classified as scalar and vector. So here I have mentioned that many physical quantities such as force, velocity, and rest physical quantities are there. For example, this is force, this is velocity. They need magnitude and direction, and they are termed as vectors. So if I say that what are the vectors, so it is very obvious from this definition that vectors are basically those physical quantities which need magnitude as well as direction. What is the main definition of our physical quantity? Vector quantities which need magnitude as well as direction. So remember this thing. This is very important thing to know, that all the physical quantities are vector quantities which need magnitude and unit and direction as well. For the combination of two vectors, we find the resultant. We will discuss this later on, as well as the size. Right? I will explain this all in your third lesson, because in your book, an order is a bit different. That's why. So as I told you in today's lesson, that for vectors, I will switch to the force, and then we will talk back about these vectors, right? So it's all about the vectors. So if I talk about the scalars over here, I told you that scalars are basically those quantities which are having only magnitude and unit. So there is no other detailed discussion of that. So um, I basically wanted to show you some contact contents of your book. So here, if I say that your book consists of scalars and vectors, something like this, and then we will discuss all those in our next lessons. This is the first topic what we have discussed, that units and base quantities, right? What is that main topic? That is your units and base quantities. Okay, it means we will talk about the base physical quantities and units, and then this all content is from your book, but I have extracted that out in terms of my own topics, or on in my own lessons, in terms of my notes. So I will prefer to go through by that method, as well as I have shown you the book here, significant figures, and that concept is there. I will address that. Then we will be talking about length measurement, and then we will be talking about area measurement, then area measurement, then volume measurement, then volume measurement, then volume measurement, then time measurements, and so on. Actually, these all are the relevant contents from your book, volume measurements, and then density and mass, weight, and density. So basically, this all is related to your measurements. So I will try my best to cover all of these areas, but in a bit refined way, right? This is the book, and I request you all to go through this book uh, at your home by your own. So no need to take prints of that all, any stuff. What I want to give you, I have provided you everything in the PDF lessons and presentation. So I hope that it will help you out. Right now, come back to the point what we were discussing in the previous 2-3 lessons. These are the same slides what we have discussed, and in these slides I have taught about the physical quantity. So I told you that in any experiment, when we are going to relate that experiment in terms of results, then those results are basically represented in terms of physical quantities, and all physical quantities consist of some numerical value and magnitude. This is really, really important, that all the physical quantities which are quantities, actually they are measurable things, they consist of magnitude, numerical value, I magnitude, and unit, right? So there are 7 physical quantities. So I was explaining that why are they base quantities, right? In this all slide, I have explained this, that why those physical quantities were called the base quantities. But anyhow, here I have mentioned this, that there are 7 physical quantities over here. For those 7 quantities, the other physical quantities can be obtained. That's why they are called your base physical quantities, right? They have different units in past, but now they have a specific unit standard, which is called your SI base unit, right? So we will talk about the SI base unit, mean international system of units, right? I have mentioned that earlier, our international system of units, system of units, right? So this all is our task and focus. Now, moving forward, I have a list of 7 base quantities, and if it would not make a mess for you people, because it is already discussed with you, but you were not having a recording of that. That's why I will use this one. That, let's say, how many physical quantities do we have as a base quantity? There are 7. So in first of all, that is mass, then this is length, then time, then current, then temperature, then amount of substance, and then intensity of light or luminous intensity. Now all of them have been explained, that mass is basically amount of matter. Its unit is kilogram, SI unit. Then distance is basically, sorry, length is distance between 2 points, right? And its unit is meter. And time is a gap between 2 happenings, right? Then its unit is second. So I was explaining it, that when our class starts and when our class ends up. So that all is basically deals with the time. So time is something. So current is basically flow of charge, and its unit is ampere. Then we have electric current, and its unit is then we have temperature, and its unit is Kelvin. And then amount of substance, and its unit is mole. And then luminous intensity, and this is made into candela. Now my main concern is length, mass, time, temperature, and electric current. So I would recommend you these 5 physical quantities to remember in your IGCSE. Rest all are used in different classifications. This is for chemistry. This is when you will be reaching at A levels, then it would be probably used in frequent way. Anyhow, let's talk about the derived quantities. Here I was going to explain that when we are talking about speed, so does what is the main important feature, that how can we calculate the speed? So speed is measured with 2 physical quantities. One is distance, and the second one is time. So all those physical quantities which are actually obtained from the combination of base quantities, they are called your derived quantities. What do we call them? They're called your derived quantities. So here I have written that over here in the term, that the quantities, that they are the combination of base quantities. And for example, speed, force, acceleration, and all that stuff. So it is Newton, it's SI unit, and it can be used as meter per kg meter per second square, right? So this was all about your first lesson we have discussed in the first lesson, or in your class number 1. Then in lesson number 2, we talked about the prefixes. Basically, today we discussed about the prefixes. And when I talked about the prefixes, I told you that actually prefix is a word or a letter which is fixed before your SI units, right? So they are letters or words to represent the multiple of 10, right? For example, if I say that multiple of 10, it is 10, it is simply multiple of 10. If I say 10 times multiple of 10, it can be 10 power 2. If I have 10 times 10 times 10, so it is multiple of 3, 10 power 3. So basically, we use them with symbols and numeric values. So here I have added some prefixes over here. I would rephrase these prefixes over here with you people. Okay, I have adjusted this all. Now, as I told you, that here we are having a number, then prefix, then number, and then prefix, mean the value of that. So let's say I told you that 10 power minus 12 is the smallest prefix what we have to now, and its name is Pico, and its symbol is small p. Then we have 10 power minus 9, it is nano, and it is represented by small n. Then 10 power minus 6, it is micro, and then it is represented by this small u type sign. And then 10 power minus 3, it is milli. 10 power minus 2, it is basically centi. Then 10 power minus 1, it is deci. 10 power plus 3, it is kilo. 10 power plus 6, it is mega. And 10 power plus 9, it is giga. And here I want to write 10 power plus 12, it is tera. So when I was talking about the prefixes, the really common example, I have figured it out for you people. That is your KB, that is your MB, that is your GB, and that is your TB, right? So I was asking that what is the speed, net speed in Pakistan? It basically oscillates from kbps to mbps, kbps to mbps. I mean kilobytes per second to megabytes per second. So this tells us that kilobyte means 10 power 3, any 1000 bytes per second, bits per second. Sorry, correction. Then mega mean 1 million bits per second, right? 1 million bits per second. So definitely this is the faster speed. But if you have 5G and that much stuff, then you will have definitely more speed. But it can be written as, to avoid the inconvenience in number of zeros, here I write 10 power 3, here I write 10 power 6. So these all are basically the prefixes concept, right? So moving towards the scalar and vector quantities, I have few examples which I have figured out for your prefixes and those prefixes, but basically I have figured that out by the topic of uses of prefixes, right? So here was this all what what did we discuss, and that was that if I have kilo, mega, giga, tera, and then I should use their numbers, right? And by using their numbers, I can figure out the conversion of one value to the other. So for example, I have figured this out over here, that let's say I have the speed of net in Pakistan that is equals to 30 Mbps to 50 Mbps. And here in your area in Dubai, one student told me that it is 180 Mbps, right? 180 Mbps means it is almost 0.18 GBps, gigabytes per second. Now, how to convert this all? I told you that here 1 Mbps, 1 MB divided by 1 GB is equals to 10 power 6 divided by 10 power 9, right? And then it would be 10 power minus 3. It means 1 Mbps divided by 1 Gbps, gigabyte, is having a ratio of 1 by 1000. It means 1 GB per second is 1000 times 1 MB per second, right? So this is what, if I'm not using the prefixes correctly, I would not be able to mention that. That's why I had told that if your net speed is 5 Gbps, then it means you are having the speed of 5000 Mbps. So this is what, this is a correlation of your prefixes. Then we should know very well about the conversion. In later on topics, we have to be we have to remember these all. So in conversion, we should know that what is 1 kilometer in meters, then what is 1 meter in centimeters and millimeters, and that stuff. So if I say that 1 meter is equals to 10 power 2 centimeters, and then 1 meter is equals to 10 power 3 millimeters, this is basically, in other words, I can write 100 centimeter, and this is what I can write 1000 millimeters. So you people are very well aware of this. So if I want to convert this back, this will be that 1 centimeter is basically 1 by hundredth of a meter, which is equals to 10 power minus 2 of the meter. This is origination or origin of the prefixes. And then I have 1, sorry, if I have 1 meter is equals to 1 by 1000, sorry, it is 1 centimeter, it is 1 millimeter. 1 millimeter is 1 by 1000th of a meter. So that gave me 10 power minus 3 meter. So as I told you, this is what, this is a sort of prefixes. So we can convert this in later on in the conversion of volume and all that stuff. So I hope that you will be getting very well in that. Then I have to talk about scalars and vectors. And there was a slide for that, what I have used with you people. The scalars are those quantities which do not need, which do not need direction, or which need only magnitude and unit, right? Their examples are length, volume, mass, speed, and all base quantities. But vectors are those which are, which need magnitude, unit, and direction, right? So their examples are force, velocity, displacement, and acceleration, momentum, moments, and torque, etc. So I was saying that if you ask to push the car with a force of 500 Newton, right? So I would definitely ask you in which direction you are going to push the car. So it means direction is important in this quantity. So this is called my force or vector. In the same way, if you ask any shopkeeper that, okay, sir, give me 5 kg of sugar, I have quoted the same example over here as I have quoted in my real lesson. So here 5 is the magnitude, kg is the unit, no direction because you don't need any direction, but you have completely described the unit, the physical quantity. So those physical quantities which are completely described by unit and magnitude only, they are called scalars. So here I told you that basically force is the vector quantity, and we will talk about all the vector rules in the chapter of force. So here I will not discuss that anymore, right? So your next lesson will be inshallah the measuring instruments and how to measure the length and volume and all that stuff. So I hope that this effort would be helpful for you. See you inshallah. If you have any question, watch this video and then ask me again in your lesson. See you. Allah Hafiz.